Hello students, welcome to my YouTube channel. In this video lecture, I am going to answer questions from sample paper number 5, RK Bali Navigation book. This is the fourth revised edition book. Nevertheless, the questions from other books, the questions of sample papers from any other book like revised edition number 6, revised edition number 5 are still the same. So it doesn't matter whether you have the most recent edition book of RK Bali Navigation or the old version. The questions of this sample papers remain the same. So let's start with question number 1. The main reason that day and night throughout the year have different duration is due to the what? So why do we have different durations of days and nights? In summers we have longer days, shorter nights. In winters we have longer nights but shorter days. So the reason for that is the inclination of the ecliptic, that is the elliptical orbit of the earth with the equator. So let's say this is your earth and this is the elliptical orbit of the earth around the sun, around the sun. Okay, right? This is the elliptical orbit of the earth around the sun. Now the equator is inclined with this elliptical orbit like this. Okay, at 23.5 degree, 23.5 degree. Therefore we have two tropics. One is tropic of Capricorn and the other one is tropic of Cancer. Okay, inclined at 23.5 degree north, 23.5 degrees south. So this is because equator is inclined. The equator is inclined with the elliptical orbit of the earth around the sun. Okay, so in the summers, when there is during northern summers, the sun will be in the northern hemisphere. That is, maximum latitude that can be is tropic of Cancer. Okay, and when it is summers in the north, there will be winters in the southern hemisphere. Now when the sun moves to a new position, that is maximum 23.5 degrees south latitude, that is tropic of Capricorn, there will be southern summers. That means there will be summers in the southern hemisphere summer. At that time there will be winters in the northern hemisphere. So this is how the sun moves. Actually, the sun is fixed, but the earth moves around the sun in elliptical orbit, and this elliptical orbit is inclined with the equator at 23.5 degree angle, and this angle makes the sun move up. Apparently move up at 23.5 degree north latitude and down to 23.5 degree south latitude. Okay, so the correct answer is inclination. Now the changing distance between the sun and the earth, that is perihelion and aphelion, that is not the deciding factor here. Changing shape of the orbit, no, irrelevant. So next, question 2. The purpose of creating networks of latitudes and longitudes. What is networks of latitudes and longitudes? It is nothing but a grid. Okay, so we have longitudes like this, we will have latitudes like this. So now there is a grid formed. Grid is nothing but a square bound by two latitudes and bound by two longitudes. So this grid, what is the use of this grid? That is the network of latitudes and longitudes. With the help of this, we are able to determine one accurate position of an observer. Let's say this observer is positioned here. We can know the accurate position of that observer by knowing its latitude and longitude. And that is only possible when we have a combination of both latitudes and longitudes together. So, for pinpointing positions on the earth. Very important question, especially for SPL Viva exam. Question 3. The datum used for measuring directions is, always remember all directions are measured with respect to north datum, with respect to north datum, that is 0 degree meridian. Okay, 0 degree uh, north datum will be a 0 degree direction. Okay, so and all directions are measured with respect to the meridian of the place. The meridian, let's say you're situated on this particular meridian 10 degree east. So the meridian that is passing through your place, with respect to that meridian, you are going to measure. Now let's say your position is 10 degree east. You want to fly a direction of 045. You want to fly a direction of 045. A direction of 045 degree. So this direction 045 degree will be measured with respect to the meridian that is passing through your position. So 045, this is your 0 degree. So 045 will be this much. So you will be flying a direction of 045 like this. Okay, always measure all directions clockwise. Question 4. Which one of the following describes the appearance of rhumb lines except meridians on a polar stereographic chart? So remember all the properties of all the charts, Mercator, Lambert's, polar. So rhumb lines on a polar stereographic chart are curves concave to the pole of projection. So option Bravo. Concave means moving away from something. Convex means moving towards something or tendency towards something. Sun is 50 degrees south, sunset is 1941 LMT. It is estimated or it is predicted to happen at 1941 LMT time. Now the observer at this particular latitude, 50 degrees south, experiences a sunset at 2113 UTC. What is the position? We have to find out longitude. So now, in this case, so LMT 19. So in case of western longitudes, if your position of this observer is to the west of prime meridian, UTC time will be more than LMT time by D long 15. If this observer is to the east of prime meridian, so in that case LMT time will be more than UTC time on prime meridian by D long by 15. So over here UTC time is 2113, LMT is 1941. So 2113 x divided by 15 will be 2113 minus 1941 is 1 hour 32 minutes. Okay, so x will be equal to 1 hour 32 minutes into 15, that is 23 degrees. In this case, x divided by 15, 1941 minus 2113, 19 hours 41 minutes minus 21 hours 13 minutes is minus 1 hour 32 minutes. So add 24 to that, you get 22 hours 28 minutes. So x is equal to 15 multiplied by that is 337 degrees. So we do not have 337 degrees, right? We have 180 longitudes to the east, 180 longitudes to the west. So that means we disregard or cancel this possibility and we go ahead with this possibility. So the longitude of this position, the longitude of this observer's position is 23 degree west, 23 degree west, correct? So what is the position? 50 degrees south, 23 degree west. Simple. Question number 6. The angle between magnetic north and compass north is called compass deviation. Simple. Now, why is compass deviation caused? Compass deviation is caused because the compass magnet, which is placed on the overhead panel of your cockpit, is subjected to many electrical influences that exist in your aircraft owing to electromagnetism. And these electrical influences will influence the working mechanism of your magnet and the needle, and as a result the direction in which this needle points is not the exact magnetic north direction, it's not the magnetic direction, but it will be compass direction. Okay, and that difference between magnetic north and compass north is called deviation. The difference between magnetic north and true north is called variation. Remember, positive or easterly variation signifies that when variation is east, magnetic direction is least. That means, let's say this is your true north. Variation is east means magnetic direction is to the east of this. Variation east. So that means magnetic direction is to the east of true direction, or true direction is to the west of magnetic one. So true north is east of magnetic north? No. True north is west of magnetic north? Yes. Magnetic north is west of compass north? Irrelevant. We are talking about variation, not deviation. In order to fly from A 10 north 30 west to B 30 north 50 west, 30 north 50 west, maintaining a constant true course, it is necessary to fly what kind of track? So by definition, if you want to fly a track of constant direction, a constant heading, you fly a rhumb-line track. Okay. Contrary to this, a great circle track is a track of constantly changing direction. But one advantage of a great circle track is that it gives the shortest distance between any 2 points. So you will fly a rhumb-line track, great circle track, drift route. So option alpha. Scoring question next. Question 9. At a fixed pressure altitude, an increase in temperature will. So I've explained this before. Your density altitude, the density of your air is influenced by three factors: pressure, humidity, and temperature. Okay, so let's focus our attention on temperature now. Whenever temperature increases, air density decreases. Air becomes very thin. Okay, air density decreases. Okay, as a result of this, density altitude will increase. Density altitude will increase. So that means you may be at a pressure altitude of, let's say, mean sea level, but your aircraft will think, it will feel that it is at a higher, much higher altitude, 10,000, 20,000, depending on the density that is existing at that mean sea level pressure altitude. So increase in temperature will decrease density, but increase density altitude, yes. Next, the coordinates of a heliport at this particular location is 48 degree north, 50 minutes. So the locations are 48 degree 50 minutes north, 2 degree 16.5 minutes east. The coordinates of the antipodal points are what? So antipodal points are nothing but direct opposite of podal points. So let's say this is your earth, this is your earth. Now here it's given one position is 4850 north, 48 degree 50 minutes north, 2 degree 16.5 minutes east. So the antipodal point will be direct opposite of that. So if this is north, this will be south. So 48 degree 50 minutes south, and the longitude will be western longitude. Uh, so remember, the sum of both longitudes will be 180 degree. This longitude, whatever this longitude plus this longitude, should be equal to 180 degree. Now we know one longitude, so 180 degree minus 2 degree 16 minutes is 177 degree 44 minutes west. Okay, 177 degree 44 minutes west. So what option will you select? Uh, so option number Charlie, you will select option Charlie. 48 degree 50 minutes south, direct opposite, 177 degree 43.5 minutes west. Okay, so this concludes a lecture. I hope you have understood all the 10 questions that I have solved and explained. If you have any doubts, if you have any suggestions, comments, feedback, let me know in the comment box. Please share this video with your friends who are also preparing for the exam, and hit the like button if you have liked this video lecture. Don't forget to subscribe if you haven't yet. I'll see you in my next video lecture in which I will solve the next new questions from this sample paper. See you.